Okay, so today's lesson is just about acid-base and gas evolution reactions, which are really just a subcategory of those precipitation reactions or double replacement reactions that we were looking at yesterday. So the first thing that we're looking at is acid-base neutralization reactions. We haven't really talked about this much, but what is an acid? An acid is a compound that tastes sour, has a pH below 7, typically begins with an H. Bases will taste bitter. They're also slippery, like soap, have a pH above 7, and typically end with an OH. So here's an example of just a typical acid-base neutralization reaction. The acid here is HCl, right? Acids typically begin with an H, and the base typically end with an OH. They combine, and they form water and a salt, and that's why it's called neutralization, because the products that it forms are neither acids nor bases. They form neutral products. And you can see here that these are essentially just the exact same thing as what we were doing before. Right? There are double replacement reactions. Hydrochloric acid is a positive hydrogen ion and a negative chloride ion. Sodium hydroxide, a positive sodium ion and a negative hydroxide ion. The positive of one hooks up with the negative of the other, and that's our HOH, or water. Remember, we can write those two compounds either way. And then the positive of one hooks up with the negative of the other, and that's our NaCl, which is salt, specifically table salt. Here's a listing of some common acids and some common bases. You do not need to have these memorized, but it's just good to remember that, yeah, acids generally will begin with hydrogen, and bases will generally end with hydroxide. And that's how they neutralize each other, because the hydrogen and the hydroxide form HOH. So here is another example, right? Here's our acid, H2SO4, made of H plus and 2 minus sulfate ions, potassium and hydroxide. Same thing we were doing yesterday, the positive of one and the negative of the other. That's how I get my water, or HOH, and then the positive one and the negative of the other. That's how I get K2SO4, right? The crisscross the charges. I would get K2SO4, and then I would have to use coefficients in order to balance it, just like we were doing last time. So here's an example, write the balanced and the net ionic equation for the reaction between aqueous HNO3 and aqueous CaOH2. So HNO3 and calcium hydroxide, right? The first thing we want to do is write what the ions are that these are composed of. And we can get those off of the periodic table, things like that. Now I go positive of one, negative of the other, and one of them should always be HOH, or water, and that's a liquid. And then the other one, positive of one, negative of the other, and this is Ca parentheses NO3 2, and according to the solubility rules, that's aqueous. Now I'll balance it. So this is where I balance these. I'm going to balance it by putting a 2 here and a 2 here. Now I go, in order to get the net ionic equation, I separate out anything that's aqueous. So 2H plus aqueous plus 2 NO3 minus aqueous, right? This 2 applies to both of them, plus calcium 2 plus aqueous, plus 2 hydroxide aqueous. Now I don't separate out the water. I'm going to write it just as regular water this time. And I don't separate it out because it's a liquid. And now I cross off my spectator ions, right? So those are the ions that appear as ions on both sides. So calcium I get to cross off, and the nitrates I get to cross off. So my net ionic equation is 2H plus aqueous plus 2OH minus aqueous yields 2H2O liquid. And we can actually simplify that. H plus OH minus yields water. So it was really no different than what we were doing yesterday or what we were doing before, except now the product is not going to be a solid. One of the products will be liquid water, and it will always be liquid water. Acid-base reactions always form liquid water as a product. So here's another one, okay? You can pause here, try this one on your own, or go through and listen to me do it. Write the balanced and net ionic equation for the reaction between aqueous perchloric acid and aqueous barium hydroxide. So perchloric acid, you're like, I don't know what that is. Well, that's why I gave you this table. So we can go look. Perchloric acid is HClO4, okay? So this is HClO4. All acids are aqueous. Barium hydroxide is also aqueous. And what are they going to form, right? Look at the ions that they are made of. The positive of one and the negative of the other. There's my water. And barium perchlorate. And that's aqueous, right? It wants the net ionic equation also. I break up everything. That is aqueous on both sides. Oop, I didn't balance this. There we go. 2H plus aqueous plus 2ClO4 negative aqueous plus Ba2 plus aqueous plus 2OH minus aqueous yields 2H2O liquid plus Ba2 plus aqueous plus 2ClO4 negative aqueous. Cross off my spectator ions. That's my perchlorate, and that's my barium. So again, look at what has happened. 2H plus aqueous plus 2OH minus aqueous yields 2H2O liquid. And we can simplify that because it doesn't really need two of each reacting. All you need is one of each reacting. Right? And did we notice that the net ionic equation for the last one is the same as this one? And that will happen. Neutralization reactions make water. A gas evolving reaction is the exact same thing. You get the positive of one and the negative of the other. But when we do that, when we take the positive of one and negative of the other, that product happens to be a gas. So this is an example of one that one of the products is directly a gas. Sometimes you will get one where one of the products is aqueous, but this H2CO3, it's carbonic acid, FYI, will rapidly decompose into H2O and CO2. That's why it's in blue here, because these become those rapidly. So if I mix HCl and sodium hydrogen carbonate, that's actually the fancy formula for baking soda, I'll make water and carbon dioxide gas and salt, NaCl. So here are compounds that undergo gas evolution reactions. So if you have a sulfide ion, a carbonate, or bicarbonate. Bicarbonate is hydrogen carbonate. Sulfites and bisulfites. Sulfite is SO3 2-, bisulfite is H SO3-, and ammonium, remember, is NH4+. When those polyatomic ions will react with an acid, they will gain a hydrogen, And you can see here's the gases involved. Some of them, these guys have an intermediate where they will form those compounds, and those compounds will quickly decompose. Okay, the one that is really important for you to know actually is this one. That's the one that I would ask you to know for the test. The rest you can use this as a help. So the formula for acetic acid reacting with baking soda. So if you go back, acetic acid is H, and you can write, acetic acid can be written like this or the other way, NaHCO3. We are doing the exact same thing, the positive of one and the negative of the other. Positive of one, negative of the other. H2CO3, and that's aqueous, but when I see that, a little light bulb goes off that says that's going to decompose. The other compound that's formed is sodium acetate, and that's aqueous. So when this guy, he immediately decomposes into H2O liquid and CO2 gas. So if I were to write this equation, I could just write it as HC2H3O2 aqueous plus NaHCO3 is a solid. It doesn't say it's a solution. And then arrow, H2O liquid plus CO2 gas plus NaC2H3O2 aqueous. If I were to write a net ionic equation for this, the only thing that is aqueous on both sides would be the acetate ion. So that would be my spectator ion. Okay, here's another example. Write a complete balance for the gas that when you mix aqueous nitric acid, HNO3, and aqueous sodium carbonate, that's Na2CO3. Right? So let's see, H plus, NO3 negative, Na plus, CO3 2 negative. So crisscross the charges. Again, I get that H2CO3, but this sticks out that this is going to decompose, and NaNO3. And this one, I'm going to have to balance it that way. And so I can rewrite it 2HNO3 aqueous, acids are aqueous, plus Na2CO3 aqueous yields H2O liquid plus CO2 gas, because I know that's what that decomposes into, plus 2NaNO3 aqueous. Okay, so those are the examples. Now you can go ahead and try the corresponding homework problems.